Hi, we're just outside the Oakland Alameda County Coliseum Sports Complex. Most people come here to watch the Warriors, A's, and Raiders play basketball, baseball, and football. But we're here to do some carpool chemistry. Today we're going to determine the actual molecular formula from simplest or empirical formula and its molar mass. So let's say you're given the formula CH2O, which is a simplest or empirical formula. You're also given the fact that the molar mass of this compound is 120.12 grams per mole. You're asked to find the molecular or actual formula. Well, this is the simplest formula, but is it the actual formula? Well, to start off with, let's go ahead and write down what we really need to find. So we're looking for some formula, and let's write down a skeleton structure. Some formula C something, H something, O something. And we know that we need to fill in those blanks with the number of moles. They need to be whole numbers. But in this case, unlike when we calculated the simplest or empirical formula, they do not need to be the simplest whole number ratio. So not necessarily the simplest form. So what we want to do now is think of the possibilities. Some of the possibilities of this formula, just to get a general idea of where we're heading, possibilities are, well, it could be the simplest formula. We don't know for sure, CH2O. Or it could be another formula with carbon, hydrogen, and oxygen in the same proportion as 1 to 2 to 1. And another possibility for that would be C2H4O2. So that's another possibility. And yet another one would be C3H6O3. Notice how we multiplied each subscript by 2 over here, each subscript by 3 over there. And when you do that, the ratios remain the same, even though you have a different formula. And let's throw in one more. It could also be C4H8O4. We just don't know. However, we do know that there is another criteria for this formula, and that is the molar mass has to be 120.12 grams per mole. So let's write ourselves a little note. Formula must also have a molar mass of 120.12 grams per mole. Well, does this formula have a molar mass of 120.12 grams per mole? Or is it this one, or this one? Well, we could do a trial and error and calculate the molar mass of this one. And if it's not, then we calculate the molar mass of that one to see if it matches up. If it's not, then we go on to this one. And we could keep on doing it, and eventually we'll find the one that has the molar mass of 120.12 grams per mole. But that might be a little bit tedious and take up a lot of time. So my recommendation is to step 1, calculate the molar mass of the simplest formula, and that is CH2O. Molar mass of CH2O, and of course we have grams of carbon is equal to 1 mole times, and from our periodic table, 12.01 grams per mole. And I could put a little P table here just to remind myself as to where I got that from. And then we have the grams of hydrogen. 2 moles of hydrogen times 1.01 grams per mole, also from the periodic table. And let's back up over here. This first one for carbon comes out to 12.01 grams. The hydrogen component, 2.02 grams. And then finally the grams of oxygen. We're looking at 1 mole times 16 grams per per mole is equal to 16.00 grams. And when we add them all up, we're looking at 30.03 grams per mole. Okay, and let's fix this up a little bit. Let's put our mole right over there. So, is the simplest formula the one that we're looking for to be the actual formula of 120.12 grams per mole? No, it's not. It's only 30. So what we want to do is we want to ask ourselves in step 2, how many times greater is the actual molar mass than the simplest formula molar mass. And when we think of how many times greater, we normally divide one number by the other. So to do that, our actual molar mass is 120.12 grams per mole divided by how many times greater is it than the simplest one? Well, the simplest one is 30.03 grams per mole, and that comes out to be 4 times greater, because 120 divided by 30 is 4. So it's 4 times greater, which means that the actual formula would be 4 times greater than the simplest formula of CH2O. And so what coefficients do we need to make our formula CH2O 4 times more massive or 4 times larger and keep this same 1 to 2 to 1 ratio? What we do is we take our formula CH2O, multiply each subscript by 4 to get C4H8O4. And that's your actual molecular formula from simplest or empirical formula and molar mass. Thank you very much for watching, and we'll see you next time.